హలో ఆల్, వెల్కమ్ బ్యాక్ టు అవర్ ఛానల్ చమ్కు స్పార్క్స్. సో ఇవాళ మనము ఇంటర్మీడియట్ ఫస్ట్ ఇయర్ కెమిస్ట్రీ చాప్టర్ 7 కెమికల్ ఈక్విలిబ్రియం యాసిడ్స్ అండ్ బేసెస్, ఇది పార్ట్ 2 ఆఫ్ ద వీడియో. పార్ట్ 1లో మనం ఆల్రెడీ వెరీ షార్ట్ ఆన్సర్స్ క్వశ్చన్స్ కంప్లీట్ చేసేసుకున్నాము. సో మనం ఇప్పుడు పార్ట్ 2 వీడియోలో షార్ట్ ఆన్సర్ క్వశ్చన్స్ కంప్లీట్ చేసుకున్నాం. సో మనం ఇక్కడ ఫస్ట్ క్వశ్చన్ చూసుకున్నాము. What is Le-Chatelier's principle? Discuss briefly the factors which can influence the equilibrium. So first, what is Le-Chatelier's principle? If chemical reaction at equilibrium is subjected to change in temperature, pressure and concentration, the equilibrium position shifts in the direction in which this change is reduced. So this is known as Le-Chatelier's principle. So let's see the factors that are affecting the equilibrium position. So the first one is concentration. Increases in the concentration of reactants favors the forward reaction. Increase in the concentration of products favors the backward reaction. Okay, this is like vice versa. Okay. Second one, pressure. Increase in the pressure favors that reaction in which volume decreases, and decrease in the pressure favors that reaction in which volume increases. Temperature. Increase in temperature favors endothermic reaction, and decrease in temperature favors exothermic reaction. Next one, write a short note on Bronsted-Lowry acid-base theory. This theory was proposed by Bronsted and Lowry. Okay, Bronsted-Lowry acid. It is a substance that is capable of donating a hydrogen H plus ion or proton donor substance is also known as Bronsted-Lowry acid. Bronsted-Lowry base. So this is about Bronsted-Lowry acid. Now this is about base. Okay, it is a substance that is capable of accepting a proton H plus or proton acceptor compound. So this is the example, dissolution of ammonia in water. Okay, so this is the example. Now this theory is also explains conjugate acid base theory. In the above reaction, ammonia accepts one proton, so it acts as Bronsted base. Water, it loses one proton, so it acts as Bronsted-Lowry acid. Okay, coming to the next question, what is conjugate acid base pair? The acid base pair which are differentiated by one proton H plus is called conjugate acid base pair. Here conjugate acid means one proton extra, conjugate base means one proton less. Okay, example, water plus ammonia, reversible reaction, gives rise to NH4 plus OH minus. In the above example, H2O or OH minus and NH4 and NH3 are conjugate acid base pairs. A strong acid would have large tendency to donate proton. Thus, conjugate base of a strong acid would be a weak base. Similarly, conjugate base of a weak acid would be a strong base. Next question, derive the relation between Kp and Kc for the following reaction. So they will be giving an equation, so we have to find out the Kp and Kc relation for the equilibrium reaction. Okay, so this is the reaction. Now let's find out the Kp and Kc relation. So Kc is equals to NH3 whole square by N2 and H2 whole cube. Okay, so in the Kp, so it is pressure, right? So we have to apply pressure, P square NH3 by Pn2 into P cube H2. Okay, so partial pressures of Pn2, PH2 and PnH3 can be written as Pn2 is equals to N of N2 RT by V. This is like P is equals to nRT by V. Okay, so N of N2 RT by V is equals to Cn2 RT. Okay, so P of H2 is equals to NH2 RT by V is equals to CH2RT. Same for all the three given reaction formulas, we have to apply this. Okay, so PNH3 is equals to N of NH3 RT by V is equals to CNH3 RT. So substituting these values in Kp equation, Kp is equals to CNH3 whole square by Cn2 and CH2 is equals to RT into minus 2. So Kp is equals to Kc RT whole minus 2. Okay, so this is the relation for Kp and Kc for the given equilibrium reaction.